All right, so this whole chapter we've been doing systems of equalities, right? Or things that are equal to each other, systems of equations, I should say. So this time we're not doing equations. What are we doing? Inequalities, which means what do we have in there instead of less than or greater than, that kind of thing, okay? So I'm going to start off with a pretty easy example. It's not even in the book. It's just one that I made up, just to kind of get us into the swing of inequalities. Let's grab this graph. Okay. And what if I asked you to graph this? This is something that we did quite a bit last year. I don't think this, I don't know, maybe we did. Now that I think about it, maybe we did the next part as well last year. We'll see. All right, here we go. So we're going to graph x minus y is greater than or equal to negative 2. All right. Are we going to graph it just the way it looks right here? No. What are we going to do to it? Yeah, get y by itself. Put it in slope-intercept form. We're going to do it exactly the way we did just regular equations, except now we have a greater than or equal to. All right, so we're going to solve it the same way as we did before, but there may be a situation where we have to do something to that inequality. Do you remember that situation? Right, when you divide or multiply by a negative, okay, then you have to change the direction of that inequality. Did we talk about that this year? Did we? Okay, I can't remember. It seems like so many of my classes are overlapping, especially with equations of lines. I think all three of my classes, geometry, algebra 2, and this class, we've all been talking about equations of a line. It's hard for me to keep straight what we talked about in what class. So anyway, first thing I would do is get the x over here on the right side. So I've got negative y greater than or equal to. I'm going to slide the negative x in between. So I'm going to put minus x right there and then minus 2. All right, just subtracted x from both sides, no biggie. Okay, here's the one thing that we just talked about. I want y by itself, but I got a negative with it. So how do I get rid of that negative? Divide by a negative, right? Divide by negative 1, or technically you could multiply by negative 1 as well, couldn't you? That would still get rid of that negative, right? So I'd probably think of it, I mean, it's a negative 1 times y, so I'm thinking divide by negative 1. So if I divide this by negative 1, I get a positive y. Now, look what I just did. We just talked about it about 5 seconds ago. I divided by a negative, so what do I do with that inequality? Flip it, okay? So change the direction. I don't normally like to say flip it. I know what you mean. I get it. It's fine. It's not that big of a deal. But I like to say change the direction of the inequality. Because when I think flip it, what are you thinking? Fractions, right? Up and down, right? Taking the reciprocal. But you're just changing the direction of the inequality. So now you change all the signs in here too. So it was a negative x, we're going to make it positive x. It was a minus 2, we're going to make it plus 2. All right, easy enough. Now we have to graph it. Initially, we're going to graph it just like we would graph it if it had an equal sign. If it was y equals x plus 2, okay, we would graph it just like that. But there is a difference, okay? It's less than or equal to. So we come up here, y-intercept is 2, the slope is 1. So I could rise 1, run 1, but see how close that is to each other? If I'm gonna do a slope of 1, let's do this. Let's go as far as we can. Let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't you think that would be a little bit better? We stretch it out a little bit so we can be a little bit more accurate. Yeah, I think so. And you could have gone down here too if you wanted to, right? 1, 2, 3, 4, 5. And I don't know, I just picked 6 because that's how far I went up to there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. And they should line up. I just kind of like them spread apart like this because it just is a little bit more accurate. In this situation, we don't really, accuracy doesn't really come into play all that much, but there we go. Oh, I should have been careful with this. I should have said this first. Now, I did put a line here, and it is a solid line, Okay, and it is going to be a solid line, but there is a situation where it's not a solid line. It could be a dotted line. So what tells us if this is a solid or a dotted line? The less than or what? Or equal to. So if it's or equal to, it's a what? Solid line. If it just said less than, it didn't have the or equal to at the bottom, then what kind of line would this be? It'd be a dotted line. Everybody got that? All right, that's something that, I don't know, when I teach it, I just think it's kind of common sense. If it could equal it, so it's solid because it's right, it could be right on the point. If it's just less than, it's not on those points right there. So that would be shown by a dotted line, okay? Now what do we got to do? Is that it? No, because it says less than, right? This would be equal to, right? Just straight up equal to. How do I do less than? I shade it, that's right. Now, where do I shade it? How do I know where to shade it? Well, if it's less than, normally we go below the line, all right? It's pretty easy to do. But what if you weren't really sure? What if you looked at it and you're like, oh, I don't know if I shade above or below the line? Yeah, pick a point somewhere, okay, and see if it works. So let's pick a point. What's the easiest point to pick? 0, 0, all right? So let's pick this point right here and put it into this and see if 0, 0 satisfies that inequality. That's what we usually say when we, the fancy way of saying it. It satisfies the inequality. So let's put a 0, 0. So that 0 is less than or equal to 0 plus 2. So is 0 less than or equal to 2? Yeah, of course it is. 0 is less than 2. So that means this is going to be in my shaded region. Where is that in reference to the line? It's below it, isn't it? So I shade it like this. All right, that's not new. That's old stuff. And you said we've done this year, right? All right. So just a reminder, we're going to get a little bit trickier, okay, on this with this next part. So that's not even an example in the book, all right? They assume that you already know how to do this. We probably, again, went over it at some point. So now, let's change this to white and copy that. Okay, now what we're going to do is this. For some reason, I do not have an example 1 in my notes. I don't know why, but that's all right. I started with example 2. And it says solve by graphing. Solve by graphing. All right, let's put that graph here. Push it over a little bit. Can make it a little bit bigger. It's got some room here. All right. Now, this is a little different, so watch. Maybe you remember this from last year. I'm pretty sure we did this in Algebra 2. Pretty sure. We haven't gotten to it yet in my Algebra 2 class yet this year, but now look, it's not just one thing. It's 3 separate inequalities. What we want to do is we want to find out where all that shading, we're going to do shading, right, because we got that less than or greater than thing. We're going to do shading, but we want to find out where it intersects, where all the shading comes together, okay, where it's true for all 3 of these. Okay, so my shading has to include all 3 of them. You with me so far? All right. Let's do one thing before we even think about graphing. What's the one thing we want to do before we graph this thing? Yeah, solve for y right here, put that in slope-intercept form. So that's easy. So that's y is less than or equal to negative 2x plus 4. So these are the 3 things that we're going to graph. And we're going to find out where the shading intersects. Okay, so those are the 3 things we're going to graph. Since we just talked about this one, let's do this one, all right? And then we can do the other ones. The other ones aren't hard, but we just already talked about this, so let's do that. I'll go back to red. Plus 4, 1, 2, 3, 4, that's my y-intercept. The slope is negative 2, so negative 2, positive 1. Let's do it a few more times. Negative 2, positive 1, couple more. Maybe go up here, go up 2 to the left 2. All right, that's good enough. Now, it says less than or equal, so what kind of line are we going to put? It's going to be a solid line, okay? So make sure you remember that. I mean, the problem, I I will mark the problem wrong if you put the wrong kind of line, all right? If it's supposed to be solid, you put dotted, I'm marking it wrong. If it's supposed to be dotted, you put a solid line, I'm marking it wrong. Sorry, but there you go. Everybody good so far? All right, let's do another one. Yeah, let's do it in a different color. Let's go blue. Let's do this one in blue. All right, y is greater than or equal to 0. Pretend it was just x equals 0. All right, what kind of a line is just x equals a number? Okay, it's a vertical line and it goes through 0 on the x-axis, okay? When it says x equals something, then it's a vertical line. When it just says y equals a number and there's no x in it at all, then what kind of line is that? It's a horizontal line, okay? So let's do that. Now, these again are both or equal to, so everything's going to be solid on this one. All right, so it crosses the x-axis at 0 and it's a vertical line. So I'm just going to put this right here and draw that like that. We'll do the shading in a second, all right? Let's scooch this over, make it, I don't know, it's just about the same. All right, so there's our y, and what about, or sorry, that's our x. Now we're going to do our y. So it's going to be a horizontal line and goes through 0. So really, it's just the x-axis, isn't it? I was going to do this in a different color, wasn't I? Green, does green show up? Tell you what, I'm going to make that a little thicker so that I can see it. There we go. Since it's right on the axis, sometimes it's hard to see. I'll do the same thing with the blue one. There we go. That's a little bit better. And then I'm just going to do my shading in red. Is that all right? So we'll do it in yellow. Sorry. Where are we going to shade? Let's do the red one. Okay, this is the red one. Y is less than or equal to negative 2x. So the red one, it's less than. Which direction are we going to shade? We're going to shade above it or below it? Below it, right. Now, are we going to shade everything below it like we did that last one? No, because it's bounded, all right? That's what we say sometimes. It's bounded between all three of these graphs. So it's everything that's less than the red one, but it's everything that's what? Greater than, sorry, let's do the blue one. Greater than the blue one, right? So that means it's to the right, okay? If it's a vertical line, greater than would be everything shaded to the right. So it's, yeah, the blue one, it's everything shaded to the right. And then, I said that wrong. This one right here is everything shaded to the right. And the Y, it's this one right here, and it's greater than as well. It's everything shaded where? Up. So it's to the right of the blue, it's below the red, and it's above the green. So I want to find out where do they all come together, right? I'm not going to have like my shading go way out here, and this shading go way over here, and this shading go way up here. Where is the area that's bounded by all that stuff? It's just in here. Do you agree? So that is where you're shading. Did we do this last year? I think so, yeah. Even if you weren't here last year to do this, I mean, I taught this just like we never did it before, so there we go. Everybody good? I was kind of, I wouldn't say accused. Accused is too harsh of a word, but a parent during the parent-teacher conference said that I always say, do you remember this from last year? Remember this from last year? Like assuming that you already know it. But I do say that a lot. I do recognize that I say that a lot, but I still teach it as if you hadn't seen it before. Would you agree with that? I mean, I probably do say that. Remember this from last year? Just to try to trigger, but does that mean I just assume that you already know how to do it? No. All right. I didn't say that to the parent. I just listened. I didn't. So I just listened to her. But anyway, it just got me thinking, and that's fine. I don't do everything perfect. So, all right, and that's it. That's the solving. Okay. So any point in this yellow area works for all three of these. All right. So if I picked a point 1, 1, put it in here. Is 1? Let's do 1, 2. Since make it 2 different. Well, 2. Let's just do 1, 1. 1, 1 would be right here, wouldn't it? So is 1 greater than or equal to 0? Yes. Put the 1 in for the y. Is 1 greater than equal to 0? Yeah, put a 1 in here. So 1 is to be negative 2 plus 4 is what? 2. Is 1 less than or equal to 2? Yes. So any point inside the yellow will work for all 3 of these. You got it? If you had a point out here, it'll work for 2 of them, but it's not going to work for 1 of them. You see it? So it's got to work for all 3 of them. All right, enough of that. Oh, there's a second part of this, and this is pretty important because they're going to ask you to do this quite a bit. It says name the coordinate of the vertices. Name, I'll just say the vertices. Is that all right? Name the vertices. What does that mean? Name the vertices. Well, what kind of a figure do we have here? A triangle, right? Where are the vertices? Where do they come together? Where do they intersect? Well, that intersects right there. This one intersects here, and this one intersects right there. Everybody see that? So let's do that top vertex. Where is that? 1, 2, 3, 4, 0, 4, right? Let's do this one right here. That's the easy one. 0, 0. And then what's this one right here? 2, 0. Yep. And those points are pretty important. Okay, so yeah, that's it. All right. Remember doing the function stuff? F of, right? F of x, g of x, h of x, all that kind of thing. What we're going to do now, we're going to actually put 2 things in the function. So this is a function of 2 variables. So watch this. Instead of just f of x, they're going to go f of xy. You see that? And here's what they're going to do. They're going to tell you what that function is. 6x plus 7y minus 9. And they're going to ask you to find, so this is what they give you. This is given right here. They ask you to find f of 3, 5. It should be pretty simple if you understand functions. What does this mean? This means the 3 is going to go in for the what? In for the x, and the 5 is going to go in for the y. Yeah, it's just, again, it's just simple plug and chug, right? Plug them all in there and see what you get. So it's going to be 6 times 3 plus 7 times 5, and then minus 9. You do the work. I already got it written down, and you get 44. All right, so that was pretty easy. Agreed? Yeah, and that kind of leads us up to what we're going to do right now. Just seeing where I want to go with this. Okay. We're going to find, now I'm not going to really define this yet until we actually do the problem, then we'll look at it and talk about what these 2 words mean. And you might, again, here I go again, you might remember this from last year. But if you don't, it's fine. If you didn't have me last year, it's fine. We'll still teach you how to do this, okay? Find the maximum. And if I find the maximum, what else are you going to find? The minimum. Very good. Values of this function of 2 variables, x, y. All right? Everybody with me? That's what we're trying to find. Trying to find the maximum and minimum. Now, we got a lot of work to do before we find the maximum and minimum. So here's the function that they give you. Okay, it's a function very similar to what we just finished doing. So we're going to go f of xy is 5x minus 3y. And they're going to give you 4 different scenarios. On that last graph that we just did, they gave you 3 of them. We're going to do 4 of them this time. All right, so we're going to spread them out left to right just so we can give us some room to work underneath some of these. So that's your first one they give you. And this is another one that they give you. And here's another one. X is between 0 and 5. And here's the 4th one they give you. X plus y equals, or less than or equal to 6. Okay. So what we're going to do is we're going to graph this first, okay? Don't even worry about the maximum or minimum until the very end, all right? So what we're going to do, we're going to graph all 4 of these, going to find out where they all meet, okay, the intersection, I guess, of all of these graphs. Then we're going to look at the vertices, right? So they're priming you for that on that last problem. We're going to look at all the vertices, and then what we're going to do is what we just did right here. Then we're going to plug them in and see what numbers we get. And then we're going to look for the maximum, which would be the biggest number. Then we're going to look for the minimum, which is the smallest number. Okay? So we got a lot of work to do. Everybody ready? Yes. All right, so let's bring this down to here. Still a little bit of work here. Let's make this in slope-intercept form. So let's get y by itself. So I'm going to add an x this time, so less than or equal to x plus 2. All right, so I'm going to graph that. I'm going to graph this. I'm going to graph this. And then I'm going to solve for y here. So y less than or equal to negative x plus 6. And I'm going to graph that. All right, so let's do it kind of quick now. I'm just going to use one color. Take too long to do all these different colors. I'll just use red. Is that all right? So y is greater than or equal to 0. So what kind of line is that? Horizontal line, right? And it would be shaded everything above. I'm not going to worry about the shading until I get all my lines in there. Okay, then I'll worry about where we're going to shade. Because if I shaded everything above here, that means I'm going to have to erase a bunch of stuff when I put the other ones in. All right. What about this? X plus 2. So right here, and then I don't know. Let's rise what? 1, 2, 3, 4, 5, 6. 1, 2. Again, I just like to spread it out. If the rise is 1, I just don't like to go over 1 or up 1 over 1. Okay, right there. I just feel a little more confident with my line if I stretch it out just a little bit. All right, so that's that second one. What's up with this? There's no x or y, it's just an x. So that means I'm going to go yeah. Yeah, on this one, let me think how I want to explain this, because now I kind of painted myself in a corner for what I said earlier. Do you remember when you had this and it just said, you know, x is greater than 3? What'd you do? You put a 3 here, right? And then open circle, everything shaded to the right. Do you agree? What if you had this? X is between, I don't know, -2 and 3. What would you do? You put a -2 here. Let's put or equal. And then you put a 3 here. And then what do you do here? Closed, closed, and what? Everything shaded in between. Okay, that's what this is right here. Okay? Everybody got that? So what am I going to do? Put a closed circle at 0, and then go to 5. 1, 2, 3, 4, 5. Put a closed circle here, and I'm going to just go from here to here. I'm going to make that a little fatter so it really pops a little bit. There we go. Okay, you see that little bit right there? Okay. And then yeah, we're good. All right, and then we do this one right here. Plus 6, 1, 2, 3, 4, 5, 6. Slope is -1 this time. So again, let's stretch it out a little bit so I'm not just from here to here. All right, so let's go down to the x-axis. 1, 2, 3, 4, 5, 6. 1, 2 to there. Oops, still got that as a 3 point. Let's change that. now I connect from there to there. Let me just, there's one little thing here that's bugging me. I got to think about how am I going to explain this. Yeah, okay, I got it. Let's make this a little bit bigger so that we can see it. A little more detail. So now we got to figure out where we're going to shade. Now, I took those inequalities off of there, but you got it on your paper. So we want to go, the one that's horizontal, we want to shade everything above this horizontal line. But this one right here where it's +2, that second one, we want to, it's less than or equal, so we want to shade everything below it, okay? So we're above this one and we're below this one. And then this one over here, the one that, it's the fourth one with the 6 y-intercept, that's less than as well, so we want to go to the left. So what are we doing? We're going above this one, right? I'm just pointing, saying this, right? Above this one, below this one, below this one, and what's the other one we missed? In between, right, in between, okay? So watch what we're going to do. It's, yeah, we got to go above here, but we got to stay between 0 and 5. You see that? Because that one was between 0 and 5, so right there, and then look, right here. We're not going to go all the way to here, so we're not going to shade this little bit right in here. We are just going to go to here. Do you see what's being shaded now? Do you understand why I put that little line up right here? Because x can only go from 0 to 5, right? That's that one where x was in between. So I'm not going to go all the way to here, and I'm not going to shade in that little bit right there, because that would be past 5 on the x-axis, wouldn't it? So I only go to the x. So I pop that up here. So again, I got to go below this line, above this line, and what does that give us? It gives us all this stuff. I'll just shade it in. So that's our graph, and that's all our possible values, everything inside of here. And it also includes that, it includes that, here, here, and here. Everybody got that? So that's our graph. Why did we do all that? We did that to find the vertices of this figure. All right? How many sides does this have? 1, 2, 3, 4, 5. 5 sides, okay? Pentagon. So I want to find all the vertices, because that's going to help us find the maximum and minimum. All right? So I've got this one, this one, this one, this one, and this one. Okay? You understand? Okay, it's all the shaded in. It's the figure, it's the shape that's formed by everything that's shaded in. And so what I'm going to do is I'm going to write down each of these vertices. All right? And we can go out a little bit like this. Let's get rid of some of this stuff. We're going to write them over here on the left-hand side. Let's do it in white. Let's choose this point first. I'm just going the order that I did in my notes. It doesn't matter what order you put them in. We're just going to list all the vertices. So let's do this one first. And what is that? 0, 0. And then let's do, let's go up. So I got 0, 2. Everybody see that one? That's that one. Let's keep going up like here. So what's that one? 2, 4. That's why the graph is helpful here. All right, and then let's slide down to this one right here. What would that be? 5, 1. And then the last one would be this one. That would be 5, 0. So I found all the vertices. You wouldn't really be able to find the vertices unless you graph the thing. All right, so make sure you know how to graph it, find out where they intersect. Be pretty careful with this. I would use graph paper, okay? If you don't have graph paper, get graph paper. Right, because it's going to make it so much better for you. You can go to any drugstore, go to Walmart or something like that, and Target. I'm sure you can find a pack of graph paper. One pack of graph paper probably lasts you all year. All right, so So try to do that when you do these things. All right, so now what we're going to do, do you remember what that function was? I'll write it down. It was f of xy was what? 5x minus 3y. All right, so this is what we're going to do now. We're going to take all those ordered pairs, those x's and y's, going to plug it into this and see what we get. All right, we can do most of this in our head, don't you think? Especially 0, 0. If I do 0, 0, what's my, what do I get? 5 times 0 is 0, 3 times 0 is 0, 0 minus 0 is 0. Did I say 0 enough times? All right. Put 0, 2 in here. So 0 for the x, so that's nothing. Put a 2 in there, that's a 6, negative 6. Yes? 2, 4. 2, that's a 10. 4, that's a 12. 10 minus 12 is negative 2. 5, 1. Put a 5, that's 25. Put a 1, that's 3. 25 minus 3 is 25 minus 3 is 22. Okay? And then put a 5, 0 in for it. So put a 5, that's 25. That's a 0, that's 25. Make sense? Just plug and chug. Easy. So now we're finally ready to get our answer. Remember I said earlier, we got a lot to do before you get our answer. Well, we've done all the stuff that we had to do. Now what we have to do is find the maximum and find the minimum. All right? What do you think that means to find the maximum? The biggest number, that's right. So what's the biggest number here? 25. So that's my maximum. So, I don't know, down here I'll say the maximum equals 25. We also got to find the minimum, which would be which number? The negative 6, because it's the what? It's the smallest one, all right? And so we'll say the minimum is negative 6. Okay? Now, here's a way that they will probably write the answer. If you look in the back of the book, what they want to do is they want to see at what point do you find the maximum? At what point do you find the minimum? All right? So the answer that they're looking for is the minimum occurs at. That's what they say. So here's the number for the maximum, but what point does the maximum occur? Where does it occur? At 5, 0, right? So that occurs at 5, 0. And where does the minimum occur? At 0, 2. There you go. Does that make sense? Okay. So this is probably what you'll see in the answer key. Okay, if you do it and you look at the odd problem, if you do an odd problem and you look, that's probably what they're going to say. Again, I wrote in my notes, the minimum occurs at, all right, and the maximum occurs at this point, all right? So that right there is what they want, all right? So where's 5, 0? It's this one right here. Oh, sorry. Oh, 5, 0, I was thinking going up. Yeah, 5, 0 is this point right here. Okay, that's the maximum value, and then the minimum value is at 0, 2, which is this one right here. I probably, if I was to do that graph and I said just look at it and tell me the maximum minimum, do you think it would be intuitive to say that that right there was the maximum value? Okay, probably not. And that one right there is the minimum value? Again, probably not. I don't know if I'd be able to just look at that and say. So that means you got to go through all this, find all the vertices, because I don't know which one is the max, which one's the min. All right, so I'm going to write them all down, plug the numbers in from your function, and see what you get. There's a lot of stuff to do, wasn't it? But was anything on there really that difficult? The shading probably was the most difficult thing, all right? But finding out where they intersect, right, the intersection of all these, that's really what you're looking for. Okay, you're really looking for where all these lines intersect. They intersect here, 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 and here. This little bit right in here might have been a little confusing, popping that line up, that little line at 5, 1. That might have been a little bit confusing right there. But remember, this one said you can only go from 0 to 5. So if you go beyond 5, that's not going to be included in your shading. All right, so you should know you got to just pop it straight up right here. A little confusing, but once you get used to it, it looks complicated, right? If you walked in the door and you saw this, you're like, oh my goodness, I'd never be able to do this. But really, we took step by step, don't you think? Yeah, we started off kind of easy, worked our way up to it, build up to it. So I think that's not so bad. We do have some more to do. It's the same kind of thing. Example 3 is very similar to this. It's just a little bit more complicated. All right, these, like these right here, are just a little bit more complicated. All right, the shading is going to be, but it's really not much different. Not much. All right, so we'll do that tomorrow. All right, I did break this up into an A and a B, didn't I? Anybody look at the? Does anybody look at the lesson plans on? Yeah. So 9 to 15. Now, what we did right there may not be on 9 to 15. All right, I think I might have gone a little bit further than what I did last year, the first day. So let's just do 9 to 15. Section 2.6. We'll call it 2.6a because I'm going to give you another section tomorrow. So I'll teach that one more. I'll teach you one more example tomorrow, and then I'll give you the rest of it tomorrow. So that's your homework right there. Just do 9 to 15. I don't think. Does anybody get their book open real quick? 15. Does it cover this kind of stuff? I kind of doubt it does. Does it start at the next section?
Yeah, it's
13 to 15 are like this?
Are all in the same section.
Okay. So you do have a problem like this from 13 to 15? Okay. So you have 3 problems, 13, 14, and 15. They do look like this. Okay? All right. That's all I got.